question. Given that f of x equals to cos ax minus cos bx by x square, where a and b are real constants, is continuous at 0. So limit x tends to 0, f of x is given as cos ax minus cos bx by x square. That equals to limit x tends to 0. Here apply cos c plus cos d formula. Cos c plus cos d equals to minus 2 sine a plus b by 2. So here minus 2 sine c plus d by 2 sine c minus d by 2. Limit x tends to 0, minus 2 sine of ax plus bx by 2 into sine of ax minus bx by 2 divided by x square. That equals to limit x tends to 0, minus 2 into sine of a plus b by 2 into x into sine of a minus b by 2 into x. Give this x to 1 sine here and one more x to 1 sine here. So from the standard formula of limits, limit x tends to 0, sine of kx by x equals to k. That equals to minus 2 into a plus b by 2 into a minus b by 2. So 2 gets cancelled here. Minus of a square minus b square by 2. That equals to b square minus a square by 2. So whatever the value we got here, it is equals to limit if x equals to 0. So whatever the function is given, this is equals to the given limit, the given f of x. So the function f of x is continuous at x equals to 0. Next is 15th question. Find the derivative of sine 2x from the first principle. The function f of x is given as sine 2x. From the first principle, I can write that f dash of x equals to f of x plus h. Sorry, limit x tends to 0. Limit h tends to 0. F of x plus h minus f of x by h. That equals to limit h tends to 0. F of x plus h here is sine of x plus h into 2, or 2 into sine of 2 into x plus h minus sine 2x by h. That equals to limit h tends to 0. This becomes sine 2x plus sine 2h. So expanding sine of a plus b, I get sine 2x into cos 2h plus sine 2h into cos 2x minus sine 2x by h. So sine 2x and sine 2x, taking it as common, limit h tends to 0, sine 2x of cos 2h minus 1 by h plus sine 2h by h into cos 2x. So I took sine 2x common in these two terms. That equals to limit h tends to 0, sine 2x into cos 2h minus 1 can be written as minus 2 sine square h by h plus limit h tends to 0 sine 2h by h into cos 2x, that equals to, so here 1 sine h by h becomes 1, and I'll get limit h tends to 0 sine 2x into minus 2 into sine h into sine h by h plus limit h tends to 0 sine 2h by h equals to 2, so this is cos 2x here, that equals to sine h by h becomes 1, and applying limit h tends to 0 it becomes 0, so this is 0 plus 2 cos 2x. So the differentiation of sine 2x equals to, what we get is cos 2x into 2, which is 2 cos 2x. Sixteenth one, find the lengths of subtangent subnormal at a point T on the curve x sin y and given are x equals to a into cos t plus t sin t, and y equals to a into sin t minus t cos t. So first find dy by dx. Dy by dx equals to dy by dt by dx by dt. So first differentiating y with respect to t, I get a into differentiation of sin t is cos t minus, apply UV rule here, so differentiation of t is 1 into cos t plus t into minus sin t divided by a into dx by dt is differentiation of cos t is minus sin t plus differentiation of t is 1 into sin t plus t into cos t. A gets cancelled here, that equals to cos t minus cos t is 0, and minus into minus becomes plus t sin t by t cos t, that equals to tan t is the differentiation of dy by dx. So length of subtangent equals to f of a by m. So m is the slope here. We know that dy by dx equals to slope, so here tan t equals to m, and my point is f of t by m. This y here indicates f of x. F of x is given by y here. F of x equals to a into sin t minus t cos t. So f of t will be the same thing, a into sin t minus t cos t. So length of subtangent will be equals to a into sin t minus t cos t by m is tan t. So this is the length of subtangent, and length of subnormal equals to f of t into m, that equals to a into sin t minus t cos t into tan t. So we need to put modules for these two because lengths are always positive. So these are the values of length of subtangent and length of subnormal. And the next question is 17th question. 17th question. The volume of a cube is increasing at a rate of 9 cm cube per second. How fast is the surface area increasing when the length of the edge is 10 centimeters? So given that the volume of cube is increasing, so let us say dv by dt equals to 9 centimeter cube per second. We know that volume of cube equals to x cube and the surface area equals to 6 into x square. Differentiating volume, I get dV by dt equals to 3x square into dx by dt. I differentiated volume with respect to time. I got dV by dt equals to 3x square into dx by dt. dV by dt is given as 9, that equals to 3 into x square into dx by dt. So from here I can write that dx by dt equals to 9 by 3x square. Differentiating the surface area with respect to time, dA by dt equals to 12x into dx by dt. The value of dx by dt is 9 by 3x square. So x gets cancelled. This is 3 times. So 36 by x. X is given as 10 centimeters here. So 36 by 10 equals to 3.6. So area is varying at 3.6 centimeters square per second. So this is changing as 3.6 centimeters square per second. This is the rate of change of surface area of the cube. Next question is the 18th question. So this is section C. If P and Q are the lengths of the perpendiculars from the origin to the straight lines, then we need to prove that condition. So given straight lines are x into secant alpha plus y into cosecant alpha equals to a, and the other line is x into cos alpha minus y into sin alpha equals to a into cos 2 alpha. So these are the given equations. P is the length of the perpendicular to the first equation. Equation 1, equation 2, let's say. So P will be equals to modulus of, since these distances are given from origin, substitute the origin point in this equation. So I'll get 0 plus 0 minus a by square root of secant square alpha plus cosecant square alpha. This is P value, that equals to a by secant square alpha equals to 1 by cos square alpha, and cosecant square is 1 by sin square alpha, that equals to a by, taking the LCM, it becomes sin square alpha plus cos square alpha into sin alpha into cos alpha, that equals to a into sin alpha cos alpha. Multiplying and dividing with 2 here, I can write this 2 sin alpha cos alpha as sin 2 alpha. Sin 2 alpha into a by 2. So this is the value of P. Similarly, Q equals to distance from this equation. So it is 0 minus 0 minus a cos 2 alpha by square root of cos square alpha plus sin square alpha, that equals to a cos 2 alpha. So I got P equals to a by 2 sin 2 alpha. That implies sin 2 alpha equals to 2p by a, and Q equals to a cos 2 alpha. That implies cos 2 alpha equals to Q by a. Squaring and adding these two equations, squaring and adding these two, sin square 2 alpha plus cos square 2 alpha equals to 2p by a whole square plus q by a whole square. So this is sine square to alpha plus cos square to alpha, which is equals to 1. That equals to 4p square by a square plus q square by a square. That implies 4p square plus q square equals to a square. So this is the required condition, and this is the required condition to prove 4p square plus q square equals to a square. Next is 19th question. 19th question is a theorem from the pair of straight lines. So you can check this in the textbook. Next is 28th question. Show that the lines joining the origin to the points of intersection of the curve and the straight line are mutually perpendicular. So given equation is that x square minus xy plus y square plus 3x plus 3y minus 2 equals to 0, and the straight line given is x minus y minus root 2 equals to 0. So we need to homogenize this given pair of straight lines. On homogenizing equation 1 with equation 2, I can write equation 2 as x minus y equals to root 2 and x minus y by root 2 equals to 1. So homogenizing equation 1, I get x square minus xy plus y square plus 3x into x minus y by root 2 plus 3y into x minus y by root 2 minus 2 into x minus y by root 2 whole square equals to 0. So x square minus xy plus y square plus 3x square minus 3xy by root 2 plus 3xy minus 3y square by root 2 minus 2 into x square plus y square minus 2xy by 2, that equals to 0. On taking the LCM is 2 root 2. So 2 root 2 x square minus 2 root 2 xy plus 2 root 2 y square plus, so here I have root 2, then multiply 2 for this, so 6x square minus 6xy plus, so multiply 2 again here, 6xy minus 6y square minus, I have 2 here, so multiply root 2 for this, 2 root 2 x square minus 2 root 2 y square minus 2 root 2 into minus 2 is plus 8 root 2 xy equals to 0. So 2 root 2 x square, 2 root 2 x square gets cancelled, and 2 root 2 y square minus 2 root 2 y square gets cancelled, minus 2 root 2 xy, and this is minus 6xy plus 6xy gets cancelled. I have 6x square minus 6y square plus 6 root 2 xy equals to 0. The coefficient of x square plus coefficient of y square equals to 6 minus 6, that equals to 0. So whenever we get coefficient of x square plus coefficient of y square equals to 0, we say that the lines are mutually perpendicular to each other. That implies lines are mutually perpendicular. So this is the required proof. Next is 21st question. Find the angle between the lines whose direction cosines are given by the equations 3l plus m plus 5n equals to 0 and 6mn minus 2nl plus 5lm equals to 0. Rewriting the first equation, m equals to minus 3l minus 5n. Substitute the value of m here. 6n into m is minus 3l minus 5n minus 2nl plus 5l into m is minus 3l minus 5n, that equals to 0. That implies minus 6n into minus 3l is minus 18nl minus 30n square minus 2nl minus 15l square minus 25nl equals to 0. That implies this is minus 30n square minus 15l square minus 18 minus 2 is minus 20 minus 20 minus 25 is minus 45 nl equals to 0. So dividing this with 5, I get minus 6n square minus 3l square minus 9nl equals to 0. And again dividing with minus 3, I get 2n square plus l square plus 3nl equals to 0. So rewrite this equation: 2n square plus 3nl plus l square equals to 0. And factorizing this, I have 2n square into l square. So multiplying these two, 2n square into l square, we can split it as 2nl plus 1ln. So 2n square plus nl plus 2nl plus l square equals to 0. So taking out 2n common, n plus l plus, this is taking out n common, 2n plus l plus taking out l common here, 2n plus l equals to 0. That implies 2n plus l into n plus l equals to 0. So 2n equals to minus l, n equals to minus l. From the first equation, we have that m equals to minus 3l minus 5n. So m equals to minus 3l minus 5n. If l equals to minus 2n, then m will be equals to minus 3 into minus 2n is 6n minus 5n, that equals to n. So m equals to n. So l equals to minus 2n implies l by minus 2 equals to n, that equals to m. Here if n equals to minus l, m will be equals to plus 3l minus 5n, that equals to minus 2n. So m by minus 2 will be equals to n. I can write that l by minus 1 equals to m by minus 2 equals to n by 1. And here it's l by minus 2 equals to m by 1 equals to n by 1. So minus 2 comma 1 comma 1 and minus 1 comma minus 2 comma 1 are the directional ratios. So cos theta equals to a1 a2 plus b1 b2 plus c1 c2 by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. That equals to minus 2 into minus 1 plus 1 into minus 2 plus 1 divided by square root of, this is 6 and this is root 6. So minus 2 into minus 1 is plus 2 minus 2 gets cancelled, that equals to 1 by 6. So theta will be equals to cos inverse of 1 by 6. This is the required angle.